how's the day today so far? We got a lot of information. Yeah, good. So I'm sharing a few more information, a few more experience, what we had. Okay, so this is how we build application today. It's not like 10, 20 years back. Now, when you building application in cloud native era, writing code to run in production, having a lot of intermediate between tasks we have to do. Like we may have to deploy your development environment, testing environment, and do a lot of integration testing, unit testing, do a lot of scanning. There are a lot of stuff we have to do in between writing code to run in production. So these tasks are like repetitive tasks. So every product release, we have to go through this task. And this is where now a lot of people are trying to build a platform to cover this in-between tasks. So this is the Gartner hype cycle. So in last year, you can see the platform, internal developer platform are in the top in the hype cycle. And the internal developer portals and all these platform stories are in the top in the hype. So basically what's happening, like everyone try to start building this platform. Still, because of the hype cycle in the hype cycle, we don't have a standard, we don't have a like a very good stories to share with everyone. So people are still trying, innovating in this space. In my talk also, I'm trying to share some of our experience, what we gather while building this internal developer platform. Right. So we build a platform called Choreo. It's an internal developer platform. And so while, okay, so what is Choreo? So basically, when you come to the internal developer platform, like I said, still there's no standard. There's no correct definition. So this is our definition. So basically, what we are thinking, internal developer platform is not just the operational platform. It should cover the software designing and architecting aspects as well. So when it should be covered the how your organizational team structure, how they can create application, and how they can design, collaborate while developing their application, and then how this application can manage in production as well. So it's cover both full software development life cycle. So while building this platform, we face a lot of challenges. So here I'm listing few of these challenges. One is the scalability. It's not only the runtime scalability, how you run large scale. It's all about runtime scalability, software engineering scalability, and the support scalability as well. So when you say software engineering aspect, so now this is like a massive complex platform. So I will explain what are the complexity while go through the detail. So when you are trying to build this kind of platform, there should be multiple teams, should be interact, collaborate. So then we should have a proper architecture in place because there are simultaneous developer teams building some of the functionality, and this functionality can how you can integrate together in the deployments times. Then the next aspect is the multi-cloud or multi-regional deployment. So initially we start building our platform on top of Microsoft Azure platform. Then there's a customer demand to run on AWS. Then there's a customer demand to run on GCP. Then some customers want to run on on-prem. So because of that, even though we start with Microsoft Azure, then later we identified, okay, you can't just deploy your platform into the different cloud provider if you have a very tight couple with the cloud provider services. Then I will explain what the strategies we took overcome to these challenges. And then other thing is to run anywhere. Like I said, now even though we some of your data in maybe in the Azure or AWS, but if you many of your companies having the multi-cloud strategies in their enterprise organizations, right? So then this platform need to be run close to your data. That means you have to deploy close to your anywhere you are having your data. Then they increase the feature release velocity. Now, so if you tightly couple your platforms with the cloud provider services, for example, if you couple with the Microsoft Azure Log Analytics, then when you're deploying into the AWS, you have to use the AWS CloudWatch. Then if you deploy into the GCP, you have to use the Stackdriver. Now, when you do a feature release to touch this log aggregation kind of feature, you have to do releases, multiple releases across support all the cloud providers. So having cloud provider agnostic stack help us to increase the feature release velocity. So when we releasing a feature, it will be working across all cloud providers because of that. Then compliance adherence, obvious because of the now lot of regulatory enforcement. For example, in EU region, they can't expose their data into the US region, same as the US region. Now you have to keep your data in the US region. Likewise, different regulatory enforcement. So because of that, when you are architecting this platform, you have to make sure your data is not going around the world. You have to store your data within the region or within the cluster, and let's see how you can do this kind of deployment. Then the zero trust security. Now, because of now we are building our application to cater the large audience, right? It run on in internet basically. Now, when you are with the microservice architecture, we do frequent releases. Now, as a release management point of view, if you want to manage security aspect for every release, it will be a nightmare. So while having this platform, if that platform supports zero trust security inbuilt, when you are building an application, it's easy. So this is how we want to have a zero trust inbuilt. Then enterprise governance. Then the large enterprises run multiple teams across in the application development space. Now with the microservice architecture, they can use different languages to develop different applications. Now, what happens when you are having this kind of flexibility? There's the innovations easily can do. Again, there's some aspect of the governance also we have to consider. How you can manage your APIs, how you can observe your APIs are behaving. All this can be you have to achieve through the API management governance. So you have to think through while developing this platform. Then the observability and monitoring, because especially when you are developing a microservice applications, it's a distributed system now, right? So debugging a microservice application is a nightmare. So you have to have a proper observability in place. It can be log aggregation to metrics collection to tracing, everything need to be collected. Otherwise, you can't do a debug in the production system with this microservice architecture. Then obviously cost optimization. It is easy to run on a cloud provider or infrastructure, but if you are not controlled, if you are not architecture is not optimized, then end of the day you will get a larger bill. So that also a problem you have to think when you are developing a platform. Let's see what are the strategies we took to overcome some of these challenges. First strategy is we separate out the control plane and the data plane. This helps us to mainly scalability and also the separation of management traffic and the runtime traffic. So because of that, we have a single control plane, but now your data plane can run on anywhere. I will explain more detail. Second one is the adhere correct architecture. You have to have architecture in place from the beginning, otherwise it will be going to be a mess when you come to the introduce new features. So we use architecture called cell-based architecture. I will give more detail. That help us to more into the scalability and also implement a zero trust network and also enterprise governance. Then, like I said, this is the best out of the decision we took over this building platform. Like I said, we initially start with using the cloud provider services, but because of the demand of running on multi-cloud or any cloud or near to even on-prem, we took the challenge and we built cloud agnostic stack in our data plane. I will explain what are the tools we use, all our CNCF tools. We integrate these all tools together, and because of that, now we can run our platform anywhere, in any cloud, even on-prem or hybrid, any sort of combinations you can run, we can run our platform now. Okay, so this is the control plane and data plane separation what we have. Our data plane is mainly, we are using the core infrastructure. We are relying on Kubernetes. And we are relying on Kubernetes, and then the basic networking and the storage are the primary dependencies we are having in the cloud provider. So because of that, because of the Kubernetes abstraction, now we build our platform on top of Kubernetes APIs. Because of that, now we can use the same control plane commands to control any cloud provider. Because of the Kubernetes abstraction are running, we are built on top of Kubernetes abstraction. So it's data plane is separate out, single abstraction now. Data plane is provided Kubernetes abstraction, and top of that we running control plane in a single region, so they can control any data plane across the globe. Then so like I said, so in our platform definition, the internal developer platform is not only for the operating people. It's also for the developers, enterprise architect, and DevOps, SRE, everyone. So Kubernetes abstraction is good enough for the operation point of view, but when you come to the enterprise architecture, that abstraction is not enough. So we brought a higher level abstraction on top of Kubernetes itself. So these are the few abstractions. We have the organization abstraction, and organization can have multiple projects. Projects is a collection of components. Component is something like microservices. So individual team can manage either single project or multiple projects. Within the project, they can have multiple microservices. That's the components. And these projects can deploy on multiple, we call it data environment. So it can be dev, stage, prod, different environment. And this environment are mapped to the data plane. Data plane is either one or multiple Kubernetes cluster. It can be a single Kubernetes cluster, it can be a multiple Kubernetes cluster. If we are running multiple Kubernetes cluster, we have a network mesh in between these clusters. But because of this abstraction now, this is enterprise level abstraction. When we are actually implementing it, underneath use the Kubernetes abstraction below this abstraction. Then from the developer's point of view, we have setup abstraction as well. We have abstraction called component. Component can have different type of component. It can be a microservice, it can be API, it can be a scheduled task. That component can have another abstraction called endpoint or connection. Endpoint is something you expose to the rest of the world. Connection is something you consume from the rest of the world. So with this abstraction out, developer can build their application easily. Then the underneath platform provide the wiring up all this abstraction. Then this is the cell-based architecture. So in our platform, so the project is mapped to a we call it cell. Cell is something like a collection of component, and this component can talk each other within the cell, within the project freely. But if a given component want to expose to the external, you have a two expose level. It can be exposed to the internal to the organization. It can be exposed to the external to the organization. So we have two gateways. We call it API gateways. External API gateway with that manage and control the external exposability. internal API gate that manages the internal explorability. And also, when going to the egress, we also having the egress gateway. This is very important because of having this now API, AI work application you are building around with the API trends. So basically, when you're using API, LLM services in different external to your organization, if you don't manage these APIs, definitely there will be a huge cost. First thing. Then second thing, you need to understand we need to get the correct insight of what behavior of you are having AI application. So all these things can manage going through a egress gateway enforcement. Okay, so then like I said, we build a cloud agnostic stack to the data plane. This is the CNCF landscape, right? It's not an easy, it is very complex now. So you have to go through a lot of finding, you have to invest a lot of time to learn these tools, to select correct tools to use in your platform. These are the tools we choose and we are using underneath. We have using now nearly 20 plus CNCF tools underneath. We integrate all these tools together and we provide a unified interface on top of these tools. Okay, this is the snapshot of current platform, that current data plane. So you can see it's not simple, it's complex. So now developer can attach their source code with the Git repo. Then what happened, based on the Git repo, we are using a build pack. It determine, okay, what language written in that particular application, correct the correct build pack and do the Docker build and create a Docker image. And then it will go to a scan process. We're using 3V scanner for the vulnerability scanning. And this is like a CI pipeline. So we are using Argo workflow to run this pipeline. And after you build this image, after you complete the scanning, it can be pushed into the content registry. If you are having any content registry, our platform can push to the content registry. If you don't have a content registry, we running Harbor underneath to as a content registry. Then CD pipeline triggered. Then we deploy this application into the Kubernetes cluster. So we create Kubernetes artifacts, deployment, services, HPA, secret, config, everything, and then deploy it into the Kubernetes. So here you can see this octagon is a cell. When you create a project, we create an octagon cell in the Kubernetes cluster. In Kubernetes term, it's a namespace. Plus, we are using Cilium CNI. It's a Kubernetes namespace plus Cilium network policies. So because of this, now within the components running inside this cell, no one can't communicate because of the Cilium network policies. This is perimeter-based security. We deny all the traffic. Only they can communicate via our API gateway. So it can be external API gateway or internal API gateway. And now, and also all the network traffic within the cluster is encrypted. We are using Cilium, again Cilium CNI with WireGuard encryption, port-to-port encryption. So all the network traffic is encrypted. Developer doesn't want to care of it, it automatically encrypted. Then we are using Envoy and WS02 API gateway as API gateways. Then we are running FluentBit as a daemon set in every node and collect all the logs and aggregate it into the OpenSearch as a log indexing solution. We keep logs for 30 days as hot data, and we provide a user interface console using this OpenSearch query language. Developer can search their logs through this interface underneath this OpenSearch query. And then we use ePPF collect to a lot of layer 3, layer 4, and also layer 7 network data. With the layer 4, layer 3 network data, we generate the dynamic network diagram out of your applications, how this interaction each application within your clusters, and also we scrape these metrics via Prometheus, and we have enabled high availability, Prometheus high availability using Thanos. We are running 2 Prometheus. If you are familiar with Prometheus, you can't run Prometheus high available simply. You have to use Thanos to make it high available. There's another way of doing that. Also, we are using Velero as a backup for this information. We have the regional backup. If there are any disaster DR activity, we can register from the backup. And also, we are using KEDA for the make it scale to 0. If some of your application doesn't get any requests, it automatically down to the 0 replicas, and it capture the first request and hold up until your application is up and running. Then it's dispatched to the application. So we are using KEDA with HTTP add-on to make it scale 0. And we are using Helm and the Flux for the system components upgrade across the multiple clusters running on different locations. Yeah, so pretty much the beauty of this, all these are integrated together because it requires a lot of build lot of knowledge underneath because now we have 20 plus services, 20 plus tools we are integrated. Each tools having their own abstraction, their own configuration, their own upgrade systems, so everything you need to learn. But if you build this one, then from the developer's point of view and the operation point of view, it will provide a smooth platform to your improve your productivity. So far, we have spending like 4+ years now. It's 60 plus engineers, 20 plus platform engineers, and 15 plus SRE teams working around 4 years now. So it's not an easy. We build a lot of in-house knowledge to support this one, and also like I said, because of we build this platform now, we can run on anywhere, any cloud. That we can do a lot of releases very frequently because it's a single stack now. It's not cloud provider dependence. And good news is we started this one as a SaaS offering. Now it's open source, so this is a Git repo. So we are cleaning up some of our SaaS version stuff and putting into the open source repo. And we are in the process of submitting this into the CNCF sandboxing. Hopefully before the KubeCon North America, we should be able to submit. That's our plan. Yeah, so basically I invite, if you are interested, just join this, at least it's still not submitted, but it is submit. But just look at the repo and see, it's still not 100% feature parity with our SaaS version, but eventually it will be there. We are using same version in our SaaS. Yeah, so I have listed a few materials to read stuff. So I don't know if I have any questions. So good. Thank you very much.